Hello students, welcome to Source classes. So another oxidation reaction we will study again today, and that is Albright Goldman oxidation reaction. So what is it basically? As you can see, we are beginning again with the 1 or 2 degree alcohol, and this can be hydrogen, alkyl, aryl, alkynyl, alkynyl, established in 1965, and you're using a solvent which is DMSO and this particular acetic anhydride, and the product that you're getting from primary will be aldehyde and from secondary will be ketone. So the reaction is particularly useful for the oxidation of sterically hindered hydroxyl groups. Okay, so this is the main USP of this reaction. How is it taking place? You have this DMSO, which is now reacting with the acetic anhydride. So this lone pair on the sulfur is making a nucleophilic addition reaction to the C of the acetic anhydride, that is the CO, carbonyl functionality. And as we know in the addition substitution reactions, so once this comes back, the leaving group acetate will go away, and that leads to the formation of this type of a sulfonium. Okay, because it is having sulfur with a positive charge. So sulfonium intermediate is formed, which being having the positive charge on it, now the alcohol will act as a Lewis base and the sulfur acts as a Lewis acid, and in the due process, once the attack takes place, the acetate cleaves off. As soon as it cleaves off, okay, the proton from the alcohol is being taken up by the acetate, which now acts as a weak base right over here, as you can see. And then what can one think of? So it is on the oxygen it is taken. Now what can think of that again the acetate is going to attack the hydrogen attached to C. Okay, that bond breaks and a double bond is formed here, and the bond between sulfur and oxygen is cleaved off, giving you basically a dimethyl sulfide, acetate ion, and the desired ketone molecule. Let's see some examples now. Primary alcohol will be oxidized to aldehyde, and this is the hindered site. Okay, so when they say hindered site, so this is what they meant. Again, this is a hindered place, but if you use this reaction, it will be oxidized. Again, this is hindered, okay, and it will get oxidized to the C double bond O. This is not hindered, I would not say this is hindered, but again, this can be oxidized to C double bond O along with some other intermediate being formed over here. Okay, we will do this in the next lecture.